I can turn them up a little. Ten magnets instead of 6 magnets, and it's going, you know, as fast as the 6 magnet one went. It's got 2 coils instead of 1 coil. So it's partially successful, but the Mueller, the flat one with the more powerful magnets, still, you know, it seems to have more future, you know, more expansionary possibilities. So let's see. I turn on that switch and this switch, and then I turn on this switch and this switch. Okay, here we have the Mueller motor, and it's now got, having them at a slant speeds it up. And it's got a 3-phase generator above it, separate from it. I haven't hooked up the different pickups, you know, the bifiller pickups, or filled the other holes. You could go to other videos to see that. But I have hooked up right here. That's the 3-phase. And you can see it's at 5 volts and it's going up fast. And there's room for actually 3 more, but I'm going to put 2 more layers. And here's the story. If you can put in 1 3-phase without much trouble, and I didn't have much trouble as long as the coils worked, even though it's just body English stabilizing the thing, and I had a choice between a tent pole and a fishing pole, because you banish iron from the metal, it creates heat. And you try and banish bearings as well. And I took the tent pole. I'm going to put 2 more here, and if you can do 1, you can do 3, and if you can do 3, you can do 9. So when I show you the picture of the cars that can be made from this type of motor, which has tremendously good inertia. Right now the inertia is very fine. See, we're at 11 volts almost. It's generating 11 volts, and all of the pickups can go back to the batteries to keep them filled up, you know, while this can all go to the wheels, to the control boxes and to the wheels to drive your vehicle. So, you know, it's a matter of separating the generation from the motor function. And it's done quite, this is the most successful run we've had of it, you know. So 3 times 11 volts, approximately 11 volts, is going to be 33 volts, right? So it's getting up there, because 36 volts is what I was running that magnetic drive of 10 videos ago or so. And now I can run it with 1 little motor here instead of 3 or 4, like of 6 each in the old days with conventional motors. In other words, we've improved the motor. This is better than Bedini's, better than Rodin's, and it's getting better because the cores, I'm using old TV cores, and even though they're bigger, you know, for tuning, you know, long shortwave radios and so on and so forth, they've improved them. The ceramic thing makes paramagnetic, and it's going towards super paramagnetic. That is nanotechnology. There's already selling nano magnetite, which is reclaimed from water by magnetism, pulling oxide, iron oxide out of it. And you can see videos made in Japan the last 2 years of all of these exciting water ballet, dances and so on. And now they've got molecules, nanomolecules, that is iron magnetics, also for sale, but they agglomerate. They have to be coated with a thin coating of plastic, and then they can be put in a polymer. And they're going to be lighter, and they're going to be at least 10 times as powerful as these, and 5 times as powerful as the magnetite ones. So that will increase the voltage and increase the output. By the way, this is an experiment that I did just here. I put in pieces of ferrite in the centers of each to see if it improved. And it has improved. It's given me the highest reading, that I've gotten. So, now we can go and look at the car design, the initial car design. Here we show some automotive designs that use the Mueller motor with a stack of 9 generators, like the 3-phase that we just demonstrated. And if you can make 1, you can make 3. And if you can make 3, you can make 9. So you have 2 columns, and there's 2 models. And they will propel you, above 2 magnetic drives in the rear wheels. And an additional amount of energy can be gotten from an air turbine that's turned by these 2 air compressors, Venturi tube air compressors up front. And those air compressors are where the turn signals are, and actually they could continue to be a turn signal by being having LEDs set in the plastic as they begin to compress the air. And here's an example from the technology, old technology, a flugelhorn from the 18th century, invented in the 18th century. And here we used air power produced by a human to make a vibrational sound. In the 19th century, of course, we got electric machines and we all became consumers. And now in the 21st century, we're going to start to produce energy with air being compressed and make electricity. So here are 2 different models. Here's a dual 1500 water with 16-inch wheels. By the way, these are all from the solar vehicles that I made previously, so I already have experience driving these things with 1, 2, and even 3 people. And here is a dual 2000 with 20-inch wheels, 2000 watt. So they take about 15 amps to take off up an incline, and up to 18 amps to climb a steep hill. This one takes more. It's 60 volts, and this one is 48 volts. So depending on our amperage and voltage, these will drive the vehicle until it reaches 15 or 20 miles per hour, where this begins to participate. And over 40 miles per hour on the highway, this will be producing between 8 and 16 amps. So I call this conception, which, by the way, these are the only place to put these wheels, because there's 4 wheels on the car, and these got wheels too that are only a little smaller than the wheels here. So you see, these are not arbitrary places I'm putting them. This one is up at a 30-degree angle from that, from the wheel, so that it can be accommodated, and also the feet of the driver. Another thing is the weight. The driver is always centered in the weight, because the vehicle is very light. So you don't depend on motors and differentials and heavy batteries and stuff, to think. Another aspect of this is that at revolutions of 1,000 and more, 2,000 say, these serve as gyroscopes. So over 40 miles per hour, you cannot roll over on the highway. It's impossible. These maintain a vertical axis. And the air turbine, as it turns at higher speeds, maintains a horizontal axis. And you have to be careful, because if this went, say, 10,000 revolutions, then you wouldn't be able to steer. But at 2,000 revolutions maximum, it'll actually add stability to your steering, you know. So that's an aspect, you know. And I call this the Nixie. And it nixes fuel, it nixes batteries, and it nixes plug-ins, dependent on public and official sold places or voted places. And it's all on board. So you basically got a self-propelled vehicle that will just go. And also, it's for women. It's built especially for women. And in the fairy tales, there are Nixies, you know. And the driver and owner of this vehicle will be a road Nixie, a new kind of Nixie, you know. They're not imitating macho males in their fuel cars or their executive suites and suits and whatnot, you know, acting tough and wearing war paint and so on. Real women with kids, with groceries, you know, going to school, going to church, whatever, you know, and feeling guilty about spreading poison in the atmosphere and spending money that her husband argue about. You know, we're too poor, we're going into debt, honey. You know, this alleviates that situation. The idea right now of women pushing their babies along in strollers or getting in SUVs to go to the big box store in the suburbs is totally ridiculous. You know, this is a logical and rational solution, you know, that will revolutionize actually the planet, like they're talking about this Occupy movement and so on and so forth. That we need a new social system, not based on profit, blind profit and power grabbing and warfare, you know, a great resource acquisition and exploitation. So, you know, it may be that the Japanese and Chinese do this first. It doesn't look good for the West. You know, they've invested too damn much in the old institutions and the old feudalist, you know, dictatorship. But, there's improvements. The main improvement I can think of is the core. The core of the generators and the motors here that you just saw is ferrite. And mine that you just saw is, and you could see the torque that it produced, just two of the coils, but it's ferrite, right? It's a dolce, soft ferrite, a paramagnetic material. That is that it doesn't retain electricity and it'll switch poles, so it'll take digital information. But now there's nano-ferrite. There's two kinds. There's nano, NaO4, which you've probably seen in movies of all of the dancing fluid surfaces that make exciting ballets of geometries and so on. And even 8 times to 10 times more powerful is the molecular, the body-centered molecular nano-magnetic material, which is sold in grains, but will agglomerate unless it's coated with plastic. And you'll see electron micrograms where it's the research centers have succeeded in doing it. And then it can be placed in epoxy or thermal plastics, polypropylene or polyethylene and so on, styrenes and so on, and proliferate, you know, in these powerful things. And they'll double probably the output of the 3-phase generators, like I just demonstrated, which means that these vehicles will grow in size and load capacity and speed and so on and so forth. But with the technology that I just demonstrated, we can produce these modest but very, very elegant solutions right away without, you know, pursuing some new promising technology.